So, today's session will be run by the three of us. I'm Peter. We've also got Ritesh and Luke here, all from the
Hey,
community MonSec, which is Monash CyberSecurity Club. What do we do? Well, we teach and we practice and we run competitions all related around cybersecurity, which means basically hacking stuff. Obviously, we only hack things that we own or have otherwise permission to hack, which are set up for this purpose. But what we offer is a really practical and hands-on opportunity to practice cybersecurity, which you just don't get in any other way. We have weekly sessions, workshops where we teach a different topic each week. We have challenges that run throughout the semester, and we also organise and participate in various competitions called Capture the Flags, or CTF for short, where there is a piece of like a key or a flag hidden on a system, on a computer or something like that somewhere. And by hacking into the system, you have to find that flag and you get points for each flag you find. And so that's a lot of fun and you learn a lot as well. And so there's always a competition of that every few weeks and various heaps of options online as well. And we participate in that. We field teams and we teach you everything you need to know to be able to participate in that. And it also leads to like heaps and heaps of employment opportunities. There's lots of potential there. So to join, if you just go to monsec.io/join, the instructions are all on the page there. You should definitely sign up for MSA Rewards first, which is now free. Then when you sign up for MonSec, you get a discount, and also you go into the running to win various prizes from the MSA if you sign up in the next week or so. So you should definitely do that. Otherwise, I'm going to hand over to Ritesh now, who's going to just basically do a walkthrough of some challenges, some various ways that some of the different skills you learn. Obviously, don't worry if this all feels like completely unreachable or if this feels like completely new. The way MonSec runs, everything we're going to show you today, within probably a semester or less of coming to MonSec, you'll be able to do all of the challenges Ritesh is going to show you today comfortably. So it may look a bit like overwhelming at first, but this is really just what you can achieve in a really short period of time just by coming to MonSec. And hopefully you find that interesting. So over to you, Ritesh.
Thanks for that, Peter. All right, let me just adjust my screen up there. Cool, yeah. So before we jump in, just a quick show of hands or a bit of a react in the chat there. It's obviously a bit of a different semester. We're not expecting to have in-person classes for a little while from now. How are you guys feeling in terms of just coming to Monash and this whole experience so far? Thumbs up or whatever else you want to chat. Feeling keen? One person's feeling keen. All right, understandable. Cool. Yeah, it's different for all of us, so we'll see how it goes. But this is the kind of format you can expect from us from future as well. So all of our workshops and things, classes, they'll all be the same kind of medium through this Zoom platform. So this is probably going to be live for the next semester at the very least. So just to get used to it, basically. Nonetheless, when I say the word steganography, does that ring any bells for you guys? Just that word by itself. All right, Bailey's giving me a head shake. No? All right, cool. That means we can learn what it is then. So steganography is hiding data within other data. That's basically all it is. So for example, if we have a text file or an image file, and that image file has its own obvious contents. So for example, we have a literal image of a cat here. The question is, well, if it loads, Windows is obviously not very fast. Yeah, when it does load eventually. The question is, given this picture of a cat, can we add in some more data, hide it in there in such a way that you can still view the image and download it and manipulate it, and to all intents and purposes, it's a normal image to you, but there's still that data hidden in there somewhere. Can we do that? And the answer is steganography. So we'll look at a few examples of how that's done right now. The first being this one here, which we've pulled out from a CTF repository. So like Peter mentioned, that's a capture the flag challenge. The idea being there to find a flag, and the flag is what's been hidden in these images here. This first one here, the idea behind this is that we have a JPEG image. We can see that by the extension there, JPEG. And we've hidden our flag within the image itself. So to see how we've done that, we should first of all delineate the fact that this is the image and how it appears when we view it with a normal image viewer. But the actual data for what the image itself, the file itself contains, looks a bit more like this once it loads. So the raw data just looks like this. It's a whole bunch of bits. And this is pretty much gibberish to us now looking at it like this, but obviously when we put it into an image viewer, that's what we'd see. But the idea here is we have certain regions in this file where we can add stuff in or remove things or do whatever we want. It doesn't really affect the file in terms of what it shows up as in the image finally. So this will be unaffected if we put stuff in there in that region. And this is the region we mean here. So if you look here, this gibberish stuff here, this is all the image stuff. We don't actually care about it. If we put it into plain text, it just looks like nothing. But all the way at the bottom here, we have this text, which I'll copy out so you can see it a bit clearer. So this raw image data from our file, we've looked into it and we found this right at the very end. And that's our flag, that's the plain text. But the fact that this is here and didn't affect the image at all, it still shows up to us as normal, is kind of the crux of steganography. So we can hide certain bits of data in here using that method if we wanted to. That's a cool example of doing with a JPEG. We have another example here of doing it with a different file format. So we have one with the PNG, I believe. We'll just run through that now. So I'll delete that. So the exact same idea. We have an image, it looks normal, nothing out of the ordinary here. It displays no issues at all. But again, this time we'll toss it into our hex editor. And just to restate, that's literally just showing us what the data for that image looks like, just the raw data by itself. Notice as well that because this image format is, it's a JPEG as well, that's interesting. Yeah, it's a bit differently formatted, but you have some stuff at the start here which sometimes shows up. So this is all part of the data as well and doesn't affect the image like we said. So it's the exact same deal. We look down here and we find, all right, there's a whole bunch of plain text here, which doesn't affect the image. We can just pull that out and see it. And voila, we have hidden text in our image. So that's a really basic method. You guys kind of following that so far? Just give me a thumbs up with a react if you wouldn't mind, if that all makes sense. Yeah, cool. That's a pretty basic example, but this is kind of just a taster. So we're trying to show here that there's simple and more complicated ways to do this, to hide stuff and other stuff, basically. This is the first two examples. The other one we have here is 2019, what lies within. So this one's a bit different. What we showed there was that we can hide stuff within the metadata itself directly. So we can just go to the end of the file and then shove some text in. It doesn't affect the file at all. It just had some extra data in there. That's one way to do it. The other way is with an online tool. And the reason we're using an online tool for this is because the method we're using is a bit more involved, let's say. So I'll copy the link out here. Oops, what have I done wrong? If I misspelled that. All right, well, part of any good cybersec is doing your research. So let's see if we can find this again via Google. So online steganography, if I can spell. Decoder. All right, that's the one we want. All right, that's it. So this one's a bit more involved. And the reason for that is, whereas with these, we have an image and we just plonk in a bunch of text at the very end. It doesn't really affect the image at all. This one, it's actually encoded within the image itself. So we'll try again with this one to toss it into our hex editor and see what we see. And we won't find anything this time. It's all just gibberish. Right to the very end. Nothing in there. Now that's important because obviously when you do steganography, it may not be that you want the person who gets the image file to know that there's stuff in there, right? You might not want them to go, oh, well, there's a bunch of text at the end, therefore stuff is hidden. You might want them to think it's a perfectly legit file with nothing in there. So to that effect, this image doesn't have that obvious text at the end, it actually has the data interleaved within the file itself. So to pull it out, we can pull up our tool here. We can toss in our file. Eventually, if I scroll through all these, it's called lies within. Yep. Oh, wrong one. I want to decode it. Sorry, just bear with me. Pull up our file, toss it in there, decode it, and we'll see there, it's pulled out this lovely text for us. That's the flag there. So that's just another example of how we can do it covertly. We don't need to be so obvious in the way that we hide these things within our text. I also wanted to mention there the reason why I had to change, it's a slightly unrelated thing, but why I had to do this. Is this familiar to anyone, this tool up here? All right, well, we're not going to go into it too much. It's just a side thing. This is NoScript, and what this does is it lets you modify what scripts run your web page. That's another cybersecurity thing to be mindful of. It's that we explore a lot in this field how things like server-client relationships work, and how, as a client, you have control over certain things on your web page, and how a lot of the things which you work with day-to-day IT-wise, you kind of have a lot of control over as a user. But we're not going to go too much into that. It's just a point to make, something abstract to mention about the field as a whole. So I'll show you another example now of this same concept here of hiding stuff within other stuff, but covertly so. So this time we'll use another challenge. Go back to here. This time we have a pic of a doggo to look at. Same deal as before. If I was to toss this into the hex editor, which we'll skip this time, but if I did, just take my word for it, there'd be nothing there. It'd be completely gibberish to us as human readers. But again, if we were to toss this into our decoder here and take out the interleaved, steganographically hidden text between the eyes, then as before, we have a nice plain text here, which is our flag. And if this is a natural challenge, then we could submit this and get some points to prove that we know what we're doing and we can decrypt stuff like that. So yeah, that's a good example of that. So we've shown you so far that you can do things very easily by just tossing it into the blank space of a file, that you can also toss it interleaved using an online decoder like this in a more advanced way, which is covert. But the last way doesn't even involve modifying the image. We'll have a look at that now. So I'll just close this off here. Go back to 2019. All right, now for this one, some of you may or may not know this, but the name of the challenge is so meta. And a hint I'll give you there is metadata. So does anyone want to have a guess and just tell me, given that, that hint there, where the data for this one might be stored in this image or our flag? If you have any kind of idea, go ahead and toss it in there. Welcome to all suggestions.
I don't know, within like the actual picture itself, but we can't see it right now, but it's like layered. I don't really know.
It's a good guess. Yeah, sort of. That definitely fits into the theme of what we've looked at so far. But for this one, we've been a bit creative. We haven't hid it in the file itself. We've hidden it in the file, the data describing the file, so the metadata. If that's not familiar to you, that's okay. But the idea is that metadata is the stuff which tells us the title, the size, not the size necessarily, but just extra things about the file, which isn't in the file itself. So all this stuff here, what are the dimensions? What's the ISO used when it was taken? What's the path? All that. And one thing we can do is we can hide our data in here. We don't have to hide it in the image at all. So the image could be completely irrelevant, even if somebody knows, okay, they're hiding stuff in this file. I'm going to take the file and tear it apart, see what I can find within it. If we haven't hidden it in the file itself, then there's nothing to find there. It's all just an image. So to show you what I mean by that, we're going to use some console stuff. So this is just Linux running within my machine here in Windows. It's the subsystem for Linux. Don't worry too much if this is a bit kind of uncomfortable and weird, but I'll explain what I'm doing as I go along. So we're going to first of all navigate to our directory there. That's what I'm doing here. Pico CTF 2019. So meta. So you can see obviously that that path is the same as this one here. That's just what we've done. And we can see that that's the image we have there as well, the same one. Now, what we're going to do is we're going to use this tool called EXIF tool. And what this does is it basically just shows us the metadata, or the data describing the data for this image here. So we'll try that now and see what it shows us. So it gives us a whole bunch of stuff, the title, the size, modification times, all that stuff, useful things for probably an actual file, but also we can see that the artist tag has been set to this, our flag. So we could take that out, toss it into our online competition, and get some points for it there. And just to note as well, this metadata here has no bearing on the actual data in the image itself. I mean, besides perhaps the format and the size, these things can be whatever you want, right? The document ID to an extent can be changed. The artist, the initial creator, the modification dates, all these things can be modified to hide whatever data you want to hide in that image. You can be really creative about that if you wanted to. So yeah, that's how those are three basic methods, or three kind of basic ideas as to how we could go about hiding stuff within other stuff, basically. There's a couple of other ones here, but we'll perhaps just skip those because they're a bit more involved. Yeah. Okay, so do you folks have any kind of questions or any kind of comments on that one based on what we've seen? Anything kind of not making sense? It's just an overview, but any comments you want to make?
I'll just add it throughout this. I'm a law arts student, so this is just totally new to me. So I'm just giving this a go. But so you'll forgive me. I'll probably say some silly stuff, but no, this is super interesting.
No, please. That's good feedback. So yeah, to also mention, this is not just tailored towards if you're specifically doing computer science. If you're specifically doing cybersecurity. For example, myself, I'm doing computer science and engineering, so nothing to do with cybersecurity at all. And Peter as well. He's doing engineering and law, which is, again, not cybersecurity related at all necessarily. But if you think it's cool and you're keen on it, you can definitely join. There's no necessity that you have to be studying as part of your degree. Yeah, and of course, all skill levels and stuff. So if you think it's cool, Bailey, that's definitely good to hear. No stress at all if it's not part of your degree. No stress there at all. Yeah, okay. So if that's all the comments on that, that'll probably conclude it for the steganography bit we had. I hope you guys found that useful. And just to recap, those are just some tasters. So it's not, necessarily the actual tools you'd see used in industry, but just a kind of idea of the kind of things that forensics, which is a subset of this field, might involve. So we'll now leave this stuff behind and we'll move on to the next bit. So cybersecurity, obviously, it's a massive field. I mean, there's so many things within it. There's all these categories like forensics, which we just saw a bit of. So hiding stuff and other stuff, that's steganography, which is part of data forensics. There's reverse engineering. So you're given a binary. Can you take that program apart and see how it works and, change it a bit perhaps? There's a whole bunch out there. Cryptography, of course, dealing with cryptography. It's, in the title. But what we're going to look at here is one of the more prevalent and important ones perhaps in today's day and age. It's the web side of things. So web is obviously huge, and the web as a whole is obviously changing a lot very quickly. So in terms of security as well, that's a huge factor. You need to be kind of on top of the latest techniques for ensuring your web page is secure and ensuring your kind of the way that your web pages are written are secure, ensuring your databases are secure, all that kind of stuff. So it's a really important one, and it's one which is becoming more and more important as time goes on. And we're going to show you a little demo here right now of how we can exploit certain vulnerabilities in web pages and how these can be really detrimental to a improperly maintained web page. So here's our example site. It's Monbank. This is the premier bank of Monash if you don't care at all about your security and you don't mind being hacked. It's brilliant. So we're going to try, first of all, to log in. Well, actually, it's been a while since I've done this demonstration. Do my other co-presenters know what the correct credentials are to log in as John? Excuse me. Just to prove that we can log in correctly. Do we recall?
Unfortunately not. No, sorry. I've forgotten what the actual password is.
Okay, no stress, no stress. So in that case, we're going to take on the role of an attacker. So we have this page, it's Monbank, and we know nothing about it except for the user's email, right? So we know that our victim here has this email, johnsmith@monash.edu. And our goal is, without knowing anything about him, so again, none of us know the password, we need to somehow break our way in and find his bank details, right? Can we do that? Obviously, if you're here, the answer is yes, but the interesting thing is how. So first, I'll give you just a rundown, perhaps, of how SQL works, SQL. It's a database language, and we'll just pull up some example SQL code here. Again, if this is too much for you, don't worry. It's not important at all. It's just to give you an idea of how this stuff kind of works, just an overview. Yeah.
So just to jump in here, any website or most websites that do anything more than just basically displaying static text will have a database powering everything that's stored on the website. So when you go to a website and you sign up with an account, an entry for your account is created in a database or multiple databases somewhere. And SQL or SQL is what is used to interface with that database and get data from the database and put data in the database. And on a properly configured website, the SQL is managed by the website itself. And you shouldn't be able to access the database directly because that would be a major security breach. But if the website's not set up correctly, then it may be possible to put your own SQL into the website and then basically interact with the database directly and get the website to do things that it shouldn't do.
Thanks for that, Peter. Yeah, exactly. So maybe just to reiterate then perhaps on Peter's point, what this site should be doing is it should be taking an email and a password from us. It should be checking, are those email and password combinations correct? If it is, it takes us to our login page. It shows us all our admin stuff, maybe our bank account balance, all that stuff. If it's not, it should just reject us, right? So there should be no in-betweens there. It should be either you're correct and you get in, or incorrect and you get out. That's it. You know, straight, plain and simple. What we're going to show you though is that you can get in even without that knowledge. So this is the rough overview of what SQL code looks like, or SQL. Now, don't worry at all about how this actually looks and the syntax and all of it. The idea here is pretty much just that for the database itself, so the SQL database, which is sitting on our back end here. So this is our web app, which is this thing. Our server is sitting somewhere and our database has all the records. To interact with that database, we have this kind of code. So we might say, oh, you know, for a given table, the table might contain combinations of, you know, emails and passwords. Select, you know, people with this email and then check their password. And if that password is the same as what the user has inputted, then they're correct. We can let them in. It's how it's meant to work in an actual correct situation. But what we can show here, as Peter said, is that we can interact with the database directly or indirectly from the web app, even though we shouldn't be allowed to. We can run these commands through this front end, even though we shouldn't be at all able to do that. So to demonstrate that, let's take our victim's email here, toss it in there, and we will toss in this thing here. So let's put this email into our field. Now, I'll just explain what we're doing here with this because it's a bit of text. We have the email, and then we have a apostrophe and password like pattern hash. Now, what this all means is basically this is what we wanted to see as the email. That's all correct. And then this apostrophe, it's meant to be escaping the code. So in other words, you might have, for example, in an actual web page, you know, you might have a page which looks like, I want to run this command here. I'll copy paste it. You know, I want this to be run. And they'll do that by embedding it in within other code, right? So it might be like, you know, exec, whatever, and then colon, right? Now, what's important here is that if you put in this code, which we have here, again, it's getting a bit technical, but bear with me. If you have that and you toss it in there, what this added apostrophe we put in there does is it sits in. So let's just put this in here. Let's imagine that this computer has taken our input and it's replaced whatever, right? From, let's just say, for example, sake, it's been put in here, right? Now this apostrophe we put here, it's going to think that this is the end of this one. So in other words, this entire thing is one sandwich block, right? But instead, it should be actually this entire thing here. So what we've convinced the computer to do on the server is we've said, okay, instead of stopping there, we want you to stop here and then treat the rest of this as actual code. So maybe that wasn't very clear, but the idea here is basically that we have taken an input field, which should just be taking an email, and we've convinced the server to instead execute it like SQL code, right? This stuff here. So it'll take that and it'll execute it. It'll try to do email and password, like whatever. And then this hash at the end is just to say comment. So, whatever is after this, just ignore it. Don't even care, right? So just to restate, we've given it a valid email. We've said for anything with this email and with the password like anything, which is what this pattern here is saying, just input it, print it out back to us. So let's try this. And this probably won't work, which we'll explain why in a sec. Just as diff, doesn't even matter. No, it didn't let us in. Okay, that's a shame. But we will try it again. This time with all right, there's an explanation here which we've made, but it's probably not very important. Basically, we've just changed the @a into an @p. And the reason for that is actually not important. Basically, it's a semantic, but the concept is the same. If we run this, we should, in theory, be logged in. And now we can see John Smith's entire dashboard, which we shouldn't because we don't even know his password, right? We've just gotten his email and we've broken in somehow. So just to restate there, we've convinced the server, even though we're not John Smith, we don't have his password, that he should take his email and any password at all and accept it. So we've said, if you have this email and any password, it's fine. Not the specific password John had, which is why we can get in, yeah? And from here, we can do all our malicious black hat stuff. We can transfer money, 69,420 to ourselves, whatever. All that stuff can be done from here. Now, I also want to mention here, I don't think it's part of our walkthrough, but I do believe we made this vulnerability back when we were all working on this particular demonstration. Up here on the top, so this is another concept entirely. The first one was SQL and how to make SQL code execute for us to exploit web pages. The second thing is we note that here, ID equals 1. Now that corresponds to our friend here, John Smith, or our victim rather, not our friend. We know that he is ID of 1, but we also know that the web page here is only authenticating or keeping track of who's logged in based on this ID, right? Now, obviously a actual website should never do this, but you sometimes still see some beginner, not so well made sites do this. And this is bad because it can be exploited by just doing this. We can change it to 2. And what happens now? Now we're Jane Doe. Again, we don't know this person's email or password or anything. We've just changed this ID from a 1 to a 2, and we have access to their account now. We can see their entire, their savings and their account information. We can send our money back to John even. We can send like, $69 back to him. We can say, hey, submit that if it does load. Maybe I'll just remove those symbols. Might have broken it. Hang on. Well, I think it may have gone through. Let's just check. Again, we will very securely and appropriately log back in as John by changing a number and see if we can see those transactions. Yeah, we can. There you go. You can see all these hays and probably the asdiff there somewhere down the page. So that's just a demonstration of how if a site owner hasn't properly configured their site, if they're doing things like they're setting who's logged in based on a single string in the top here, or if there's no sanitation, or other words, they're not checking properly for if the input they're given is correct, then you can do stuff like SQL, as we saw at the very start. It's just to show that with those vulnerabilities, even if they're really small, they don't seem like they can affect very much. We can do a lot of very deleterious things by breaking in and changing stuff like this. And that's using, not a lot of knowledge either. It's a fairly simple one to break in with. Does that kind of make sense to you guys? Was that clear? Any questions on that? Comments, anything at all? Would you use Monbank now that we've shown you how, secure it is? Rachel would. Rachel is a security expert. It's brilliant.
Yeah, both these vulnerabilities are pretty simple, but there are still many websites out there that have vulnerabilities that are this simple, and they've been around for a long time, but they're still out there, which is a problem. And variations of these simple concepts show up time and time again in maybe more complicated ways, but they're still out there. And this is, I guess, a massive part of cybersecurity, because so many things use websites now. Like, imagine if you're trying to build a banking website, even something much less important, much more mundane. It's really important that you get all of this right, and you're really confident that you've got all of this right, because you read in the news all the time about people have been hacked, massive companies have been hacked because you miss one thing somewhere, and that can sometimes be enough, and there are just so many things you need to check. Any questions about this, any of the demos, or MonSec generally?
I was just going to ask, with the ID thing you did before, why would it just be like a slip of someone who created this website to have left that there, or is it something that people would try and hide or secure in a different way?
So ideally, yeah, you want to hide that. What they're basically doing here is this ID is just keeping track of who's logged in, right? So in this case, it's a very simple 1, 2, 3 for whatever. But in more complicated examples, you might have they've hidden this ID as like a hashed value, right, of somebody's name or something. That's still insecure though, because if we can get their name, we can get that hash, and by accident we can get the ID, right? The ID here is just that the way that they're verifying how users are who they are is not secure. That's basically it there.
The way, yeah, basically the ID here could be considered like a row number in an Excel sheet. It's just the row number in the database. The way you need to make this secure is use an ID or use some sort of thing to authenticate this once they're logged in. That changes every time and isn't predictable. Basically a very secure password, a random string of characters which the server generates, gives to you when you log in, and then you have to prove that you're that person every time by giving that back. This happens all in the background, and that way an attacker can't just change IDs, because the IDs are all really hard to guess and they constantly change.
It's a really good question though. Thanks for asking that. Yeah. While we're here, this is an extra thing, but just something to share as well, because it's a real world example of how stuff like this can happen. There's plenty out there of smaller sites which are vulnerable, but this is a big one, so I think it's okay to share. Twitter here recently had a bug, which shows us how even in these massive, massive sites, there's still sometimes vulnerabilities which crop up. So this is my Twitter account here. They have somewhat fixed it, but I'm just going to show it to you. Basically, Twitter has a lot of features in their site which are done by client-side verification only. And like we said at the very start, the client side has a lot of things we can control as the client, right? We can tell our browsers what to do. And the problem with client-side verification is that it's all controlled within your browser. So if you turn off the protections from your browser, then you can bypass a lot of the security measures they have in place. And what Twitter did wasn't a very big bug, but it was an interesting one here nonetheless. Their gender field, they've now fixed it, but it's meant to be 30 and 30 only, right? And how they would do that is this limit used to be enforced. I'll just move this Zoom thing out of the way. Used to be enforced by, can I see it there? Yes, max length 30. So you can see this field in the browser right down there, if you can see it, max length 30, was the only thing which was keeping you from having a really long gender, for example, right? So if I change this to a 60, then I could all of a sudden submit validly. It would say it's red, but it would still submit it. Something 60 characters long. It doesn't let you do it anymore because they fixed it now, but that was a bug they had, a really minor one, but one which cropped up. It's just an example of how these things they're not just the occasional thing which happens from neglect or from incompetence. It's superfluous. It happens everywhere. It's just a part of being on the web. It's, you know, yeah, it's just part of how it is. So defending it is a constant battle, basically. That's the summary of that one.
Yeah, that's a really good example. Thanks, Ritesh. Any more questions about this or the club or anything? So just reiterate, to join the club, just go to monsec.io/join. I think if you just Google MonSec as well, we come up as the first option. Our sessions run weekly at 6 p.m. or 5 p.m. I'm not sure what time they're running this semester. One of those options every Monday. We cover everything starting from the absolute basics. So you don't need to worry about not having any prior experience. None is required. I'm basically out of things to say now. If there's no questions, that's
just to reiterate, as on Bailey's point, this is a completely interest-based club. So if you're not studying CyberSec, don't even stress. If you think it's cool, that's all you need to get in, really. And yeah, we'll build up your skills from there. So no matter what your skill level, no matter what your interest is, you can definitely get started.
And everything is online as well, just to remember. So